The question says 6.4 now says write down the equation of the axis of symmetry of H if H of x is equal to f of x minus 7 plus 2. Okay. In this situation, okay. First, I'll consider this. Remember, in grade 11, you learned that when a function is transformed, can be transformed like this. This simply means the number x minus 7 here simply means the function is shifted 7 units to the right. And then, so this means shifted 7 units to the right. 7 units to the right. And then this means shifted 2 units upward. Okay. So it's like the same graph of the parabola that we have here will be shifted 7 units to the right, and then 2 units upward. Now, remember now the axis of symmetry. The axis of symmetry of the hyperbola is just a vertical line that passes through the turning points. Actually, this line we draw here. Okay, now the turning point will no longer be at this point. The point was, we found the turning point was -1/2 and -20. The turning point was, if I zoom in to see the turning point, yes, here was the turning point, -1/2 minus 12.5. Okay, so we can zoom back. So this turning point was -1/2 and -12.5. So it will be shifted. It's the x units that will be shifted. Okay, shifted 7 units to the right. So what we do, we just plus 7 here, -1/2 plus 7, because the graph will be shifted 7 units to the right. So let's say, for instance, this is the parabola. Just a rough sketch. Let's say this was the parabola. Okay, so we just take this parabola here, which we shift 7 units to the right. You understand? And then the axis of symmetry will also change. So it was there by -1/2 somewhere here. So we plus 7. So we do -1/2 plus 7. This is equal to positive 6.5. So yeah, that's the final answer. So x, we say x equal to 6.5. Correct. Now let's do 6.5. The question says calculate the gradients of G. Now we need to be careful here to know the difference between the average gradients and the gradients of the function. So the gradient of the function is of a cubic function. Actually, any function will be the derivative of that function. So we will do, we'll split here, 6.4. We're looking for the gradient, which is okay, the gradient of the function. And then we have said that the gradient of the function is just a derivative of that function. Okay, so we're basically trying to do f prime of x. Okay, but first of all, what is f of x? We found it here. When we find all the values of a, b, c, we put. Remember, we find the values a, b, c, and then we can write the function f of x is now that f of x now. Okay, in the previous question from ABC. So now, let me first write, so basically we're looking for this. Now f of x itself is given by 2x squared plus 2x minus 12. Therefore, f prime of x will be 2. So the coefficient, the exponent over here. Okay, let me write the formula first. It's like when we have like ax to the power of n prime. This is n times a times x to the n minus 1. Now this is what you're going to do. 2 get down times 2x to the power of 2 minus 1. And then plus the exponents here is just 1. Okay, so it's going to be 1 times 2 to the x 1 minus 1. And then we do know that the derivative of all constants is just 0. So that will be 4x to the 1 plus 2x. So m f of f, not plus 2x, but just plus 2. I mean, so f prime will be 4x plus 2. Now, the question says the gradients, so the gradients will be given by this. Now, we can find the actual gradient when we sub in a point given in the graph. Here, for instance, or the question might say the derivative, the gradients of a function at a certain point, but it didn't say anything. But I'm just gonna take here. You see, if they said, for instance, at the point D, then we can sub the value of 1 in the equation to find the derivative of the gradients of the function at this specific point. But because they didn't say anything, we stop here. So we just leave it like that. This is the derivative function. Okay. Thank you.